Wow, it feels so dramatic, right? Nightmares, headaches. Let me ask you something. First of all, hello. That's all you're going to give me? Hello, everyone. That's way better. Who considers themselves to be a great front-end developer? Okay. Who considers themselves to be a great designer? Okay. Who knows how to tie a balloon? Let's see. Now, as I mentioned, I do not take any responsibilities for what happens in this session. You might have some headaches, you might have some really interesting experiences, but we need to get one thing right, and we need this to be memorable and create kind of a performance out of this. Now, you think you know how to tie a balloon. There are 4 official ways of how to tie a balloon. Now, this session is not going to be only about that, but you'll see in a point why it matters. Now, many people have balloons here. You actually were supposed to get them as you were walking in. If not, we might have volunteers on the side. So if you do have a balloon, this is how you start. You stretch. Okay? Can you do that for me? You stretch the balloon. That's a good way of doing that. Then you start blowing. Can you do that? But do it in a professional way, not like, do it well, so everybody will be proud, but just to the point that it doesn't going to blow up, just enough, right? And then comes the magical part, because now you have to pinch. How do you do that? This is how you do it. Okay? This is a professional way. So can you do that for me? All right. So now let's see. All right, what I want us to do now, just for all of it to be memorable, I want us all, on the count of 3, to stand up and throw the balloon in the air as far as you possibly can. Can you do that? It would be a nice memory. Oh, no, not yet, not yet. On the count of 3, please. Okay? So, 1, 2, 2.5, and 3. All right. Now we're all awake, and now we need to talk about the real thing. Namely, we already had a performance. Let's talk about performance, right? So, of course, there are many things happening on the web today. And the reason why I wanted to do this is for all of us to kind of have a shared experience and a shared moment, but more specifically also to kind of explore together like how much effort it actually takes to do something together. You need a plan, you need a structure, you need some sort of an idea and strategy, and it's really, really hard to get it right. So if we look at the state of the web today, and if we look into the performance side of things, this is the world we're living in. It's a very complicated world. We have a lot of people here already, but this is the world we're living in. We have 7.5 billion people, right, at this point. And 5.6 billion of them is addressable market, which makes for 3.5 billion people using an active smartphone. Out of these smartphones, we have 25% using an iOS and 75% using an Android. Now, if you look at the phone that you have in your pocket right now, chances are high that your phone is not going to be representative for the phones used out there. Anybody uses one of those? Moto G4? 3 people? Okay. Anybody using Nokia S1? No? Didn't think so. Anybody using Alcatel? No? Didn't think so. Fortunately or unfortunately, these phones are the most popular phones in the world as of today, as of looking into the previous year. They're the best sellers in South America and also in India and also in Southeast Asia, which is where the growing markets are. And if we look into these phones, they're really, really bad. If you compare them with iPhone 7, which is not necessarily the best phone out there, you'll find out that they're approximately 14 to 17 times slower. But they're also 12 times cheaper than the good old iPhone, so it's kind of a good deal. But if you look into the performance side of things, we'll find out that all of these phones perform poorly, although they're brand new and they are bestsellers, right? So if we look at the regular experience of our wonderful shiny single-page applications that we're creating today, this is the experience, right? When you start accessing the site, and I hope you couldn't recognize or you can't recognize the brands there, it might take up to 25 to 27 seconds for the, not for initial start render, of course, but for time to interactive. And that's the time nobody is going to wait. And we always end up in this dilemma where some companies will say, but Vitaly, we don't have any 2G users. We don't have even like slow 3G users. We just don't see them in analytics. They don't buy our products. We don't have to care about them. Well, maybe the reason why they don't buy is because your website doesn't work well on 2G, on slow 3G, right? So this is always like this kind of a problem that is always showing up. And if we look in the state of technology as well, in terms of networking, we'll find out that 4G has been established now, right? We should be expecting 4G in many cases, and 5G is coming up, so everything should get better. But the reality is it's not necessarily the case, mostly because we also use 1.5, 1.4 times more data every year, right? So although the quality of infrastructure is getting better, the overall quality of the connection is getting worse because we're consuming more data, right? And this brings us to an architectural problem, because how are we going to build today? How do we build with this, users in mind, with Alcatel and Nokia world? And of course, if we optimize for them, then the experience for all the other users is going to be better as well. So when we start working, and 50% of my time is consultancy, we always build using this paradigm, a pyramid, so to say. But we always think about the speed first, then we keep accessibility in mind, then scalability. This is where you have conversations about grids, breakpoint, content size, order, and so on. And then eventually style when it comes to fonts, web fonts, animations, transitions, and so on, right? And we would have conversations in that order: speed first, then accessibility, then scale. We would have properties even sometimes arranged in CSS in that order, and we'll have many the entire stack is built on top of that pyramid in mind. And you probably are familiar with this little diagram by Jason Miller. Well, how do you decide the architecture of your application? Do you go, full server? Do you go full browser? Most of the time it seems to be cool and wonderful to be on that edge, right? This is where all the shiny world living today, right? But at the same time, if you want to make it really, really fast on these kind of devices, it's really, really difficult. I'm not saying that one is bad or the other is great, right? But in the end, it would be very, very hard to make things really fast, which is why many applications are kind of moving somewhere between here and here, probably closer to this one. That's, in fact, probably what your approach is as well. And of course, we'll be using many cool things, like, we'll be using Brotli and Zofli for compression, for example, just because, of course, it's much better than gzip. But we'll be looking most of the time, not necessarily even like in compression, but mostly in performance of JavaScript, right? And if we look at the JavaScript processing times, we'll find out that on this Moto G4 or Alcatel, we end up with massive, massive issues. Even on websites that are not necessarily, broken or built poorly, just because it takes a lot of time to process JavaScript. And in fact, if we look at the state of things on mobile, we'll find out that on average, we'll be spending or serving 0.6 to 1 megabyte of JavaScript, which is a lot, because on average on mobile, we'll find that the sites are interactive in 22 to 35 seconds, which is kind of a lot of time. However, what's also interesting is that the JavaScript code coverage of top 50 sites is just 40%. Right? Which brings us to thinking really carefully and closely how we're going to structure the budgets for our performance. Now, this is probably some of you might be familiar with it. This is what Google recommends us. If you want to reach a good performance, you'll have to look into time to interactive budget of 5 seconds, which includes everything, right? Obviously, DNS lookup, TCP handshake, HTTPS handshake, and then you have 3.4 seconds on a throttled 3G connection to get something to the network, and it makes up for 170 kilobyte, which is not a lot, right? For critical path HTML, CSS, and JavaScript. And that also includes framework and your app and the router and state management and utilities. So this is why if you don't deal with Webpack at this point, there is no way out, right? And of course, this is not a big revelation at this point, but people are starting thinking about slightly different approaches at this point. One of them is we need to kind of think about adaptive performance budgets, depending if you go on mobile, slow 3G, slow 4G, or Wi-Fi. And there are tools, like just yesterday, Light Wallet was released, which allows you to plug in your performance budgets right into Lighthouse. So every time you do an audit, you'll find if you're, if you're passing the budget or not. And you can even build your own. I mean, Google recommends 170 kilobytes. You will have probably something else. And this is a nice tool that allows you to do just that, right? And then once we do it, every time we evaluate a solution, we have to think not just about the community. Of course, React is huge. And of course, Angular is huge. And of course, Vue is huge. But if you make a decision about what framework to choose, you have to think about not only network transfer time and community size, but also parsing, compiling time, and runtime cost. And specifically, when we're looking into metrics, probably somewhere around here. First meaningful faint, and also visually ready, but most of the time to interactive, right? That's the most important one that we're looking at. But that's only one side of things, of course. Because at the other side of things, we see many people doing this, right? Where you set up a dedicated 3G network. Facebook decided to run a 2G Tuesdays, right? Where the developers are encouraged to use 2G when developing on Tuesdays. And we'll also see Chrome Lite coming up with Lite pages, where essentially whenever you have save data mode turned on, or the connection speed is very slow, they can detect that, and then they serve an optimized version of the page. So at this point, we have to really think twice about not just serving a page, right? But how should the experience adapt based on network conditions, based on device capabilities, based on memory available. And there are tools for that. Like we have Network Information API that allows us to do just that. You're on 3G, you're getting this. You're on 4G, you're getting that. So for example, it might not be necessary to load web fonts and parallax and video autoplay on 2G or 3G, right? Now we can also target low-end phones with a device memory API, where we essentially serve different versions of the same component conditionally. And it's really not difficult. This is the only thing you need to do. You need to essentially check, either you can use the API, or you can also use the client in there. And essentially, this is what it's going to look like, right? We are going to check how much memory do we have. We kind of have on a low amount of memory. And at this point, device memory gives us, returns the value of the available memory in gigabyte. At this point, we're going to kind of load either a light version or a full version, right? This is kind of where we're moving at this point. But there are also more things happening. The most remarkable one of them is probably Guest.js. Anybody heard of Guest.js? That's quite interesting. It looks like sometimes we're running out of ideas of how to optimize for performance. We really do. So Guest.js takes the predictable model. So if you're using Google Analytics, you can actually guess with what probability a user is going to move to another link or go to another page. And then based on that probability, you preload the Webpack chunks that are required to load that page. And essentially, every single interactive element is getting a probability score. Then based on that, you preload chunk ahead of time. We also have priority hints coming up, where you can say that certain things are more important than the others. It goes for images. It also goes for JavaScript. And we can even have native image lazy loading with the loading attribute coming up in Chrome 75. Can go not only for images, but also for iframes. For example, we can say that image has to be lazy loaded, right? But that image is really important, so I want it to load fast. Right, so we're getting kind of a lot of control about like even granular things like the loading of images and stuff, which is actually pretty remarkable, right? So that's interesting. On the other side, we have to really dig a little bit deeper to understand how far can we go with JavaScript, right? Because we always stumble upon this issue of it just parsing takes too much time, execution takes too much time, we have to do something. Anybody using WebAssembly today? A couple of people. Well, WebAssembly is a really promising thing. It doesn't get as much credit as it should, though. So have you asked yourself, why is it that of all the things that happened in the last 20 years on the web, JavaScript that used to be, like, used to have a horrible reputation for many years. Like if you were a JavaScript developer, 15 years ago, nobody wanted to talk to you at a party. Nobody would even talk to you. Now, I think that JavaScript is pretty cool. What happened in between? Well, JIT, or just-in-time compilers, came up 2008, speeding up JavaScript execution 10 times. That was like a big deal, which actually is the reason why we have Node today, why we have all the client-side applications running today, right? And then things changed and evolved, and at this point, it feels like we might be at the same time of point of time where a new jump is coming up, and potentially with WebAssembly. And so what is it? Well, in programming, there are generally two ways of translating to machine language, right? We can use an interpreter, or we can use a compiler. An interpreter interprets code line by line, and the compiler works ahead of time. If we look into V8 and the JavaScript runtime and the main thread, we'll find out that this is kind of quite complicated. We have a lot of stuff happening. We have tons of APIs, and obviously we have the queues, and then we have an event loop. That shouldn't be too surprising to you. So where does WebAssembly fit in? Well, WebAssembly is a low-level virtual machine that runs the bytecode that is stored in WebAssembly files. And it's kind of tried to look at JavaScript and optimize the hell out of it in a slightly different way. So it's structured in a way that is easier, that it can be compiled, optimized, and run much faster than JavaScript can. Right? So this is quite interesting, but it's not supposed to replace JavaScript. It's kind of supposed to augment or support JavaScript. Because if we look into how JavaScript is executed, well, like the entire life cycle of JavaScript, there is parsing, there's compiling and optimization, and re-optimization, which is where just ahead of time compiler comes into play. And then you have execution, and then garbage collection, right? Well, in WebAssembly, you don't have that. WebAssembly doesn't take care of garbage collection at all. Essentially, you're producing bytecode that can be decoded, then it will be compiled and optimized, and then executed, right? So if we look into it from like a bigger perspective, larger perspective, it's kind of WebAssembly represented in the binary form. Sorry for the long list here. It does not need to construct the abstract syntax tree like JavaScript does. Everything is strictly typed, so everything has static types. It's much closer to machine code, and there are a few advantages. Very often you would hear about WebAssembly being this kind of nice tool if you need to port, let's say, C or C++ into JavaScript, to run in the browser, you'd probably use WebAssembly. In fact, this is like one of the use cases, right? But you can also build WebAssembly modules and optimize for them even if you have just regular JavaScript as well, using TypeScript and ImScripting. So essentially, it's like a machine, right, where you can run both on, on virtual machine, both on in a browser. So when would you use it? Well, most of the time you have very computationally heavy tasks, like maybe you have a lot of image manipulation going on, like tons of rotations and things like that. If you want to have a predictable performance across all browsers, fast predictable performance, you might want to look into actually using WebAssembly as well, right? You might think, but is it well supported? Yeah. It really is well supported. There is no reason not to use it except you know who, but we're used to it at this point, right? This is not a big deal. And there are tools as well. You can use assembly script that compiles strictly typed TypeScript to WebAssembly and just test it. Maybe it will help your performance as well. This is something that will happen quite a lot, especially if you have maybe dedicated section or dedicated segments of your experience, which are very heavy, computationally heavy. In that case, you might want to think about actually using WebAssembly for that, which is Surma calls a hot path in your apps, JavaScript, right? Another thing, again, we've been talking a lot about critical CSS for so many years, right? We know we can use tools like Critical and others to push CSS, critical CSS in the header of the page to optimize for performance and rendering as well. At this point, it seems like things are moving and shifting and changing, especially in the times of HTTP 2, and then eventually in times of HTTP 3, which is coming up with UDP. That's like a big, big shift. That's happening quite significant shift. One thing that can help, and I'm not a big fan of it, is to use atomic CSS. Anybody using atomic CSS? I probably have to explain it as well. Well, I can't sleep knowing that my code looks like this. Essentially, the idea is I want to ensure that if I have something like border radius in my CSS, there will be only one occurrence of border radius in the entire style sheet. Because very often you end up in a situation, you build a new component, right? And then you just write border radius over and over again, right? So this replaces it with kind of atomic modules. It you just start using like this. Essentially, you reduce the size of your CSS, you massively bloat up your HTML, right? But in the end, the results might be worth it because you can automate the entire thing, right? And I know what you're thinking, I don't want to do that. But it was interesting because some of the case studies highlighting the impact of atomic CSS saw two things which are very important. One of them is a drastic reduction in CSS, but the other one is normalization of CSS, meaning as the project keeps growing and you kind of move from 1 year, 2 year, 3 years, 4 years into a project, the size of CSS remains stable, unlike in most projects where it just keeps growing as the project evolves, right? This is something that might be worth exploring, especially because you can automate the entire process, right? There are also a few more things you need to do. Like Harry Roberts, I think he might be here somewhere, he did an incredible research at how you can actually kind of tweak the performance assets by looking into how we place CSS and JavaScript in our markup. And so one thing that's interesting is to avoid CSS before synchronous scripts. So if you have a CSS, which is always blocking, of course, then you have script. What's interesting there is a browser will not execute a script if there is any currently in-flight CSS. For example, if the CSS is almost fully constructed. It goes, of course, for synchronous scripts, but also in the same way for asynchronous scripts. So if you have something like this, where you have a CSS file and then you have an analytics.js, right? This is what's going to show up in the waterfall, right? So as we can see, there is quite a bit of time spent doing nothing over here, right? Because obviously that file is getting low priority, right? So if you ever read documentation from third parties, like Google Analytics and stuff, they will always recommend you to put their async scripts in the first items in the head. And you're like, no way. I'm not going to do that. I'm a reasonable front-end developer. But actually, it actually does make sense, because if you put it the other way around, kind of maximize the bandwidth, and you use both in the best way, right? So that kind of makes sense. And another way, in times of HTTP2, it might be a good idea to think about progressive CSS. So for a long period of time, we're thinking about combining, minifying, putting it all in one single file and call it a day. At this point, we kind of need to think twice about what we're doing. We're looking at different tricks and using critical CSS inline and this and that, a little bit of logic here and there. In HTTP2, it's probably better to do this. You break down everything into a number of components. Let's say maybe 8 to 10 modules or 8 to 10 bundles. But even better, what you can do is progressively load CSS. So whenever you have your site header, you can put it right in front of the header. Whenever you have your article, put it in front of the main, comments in front of the comments, and so on and so forth. And this technique was, Jake wrote about it 2 years ago or 3 years ago. And it's actually now that is more or less consistently implemented, because the result is quite noticeable. So on the left, with progressive CSS, where essentially you render the page or load the page part by part, section by section, while on the other one, on the right, it's blocking rendering, so you have to wait for the entire CSS to come through, right? And in fact, as of now, this loading pattern has landed in Chrome, Canary, but I think it might be already in Chrome as well. It's stable. So you might want to look into it. This is a slightly different way of loading your CSS, right? So that's quite interesting as well. And then finally, we do get to the bottom of web fonts. Web fonts, they're always difficult. Why are they always so difficult? I remember times when things used to be easy and simple, and you would wake up one day and plug in link in your HTML, and then you would go home to your friends and neighbors and, I don't know, dogs. And now you need to have a web font loading strategist to find out what strategy you should use, because fonts are blocking rendering, and very often they are the reason why performance suffers. So there are a couple of different techniques that have been used for quite some time. One of them is the critical fourth technique, where you have a two-stage render. Because in the end, why do we do it in the first place? Well, because we want the fonts to come in very quickly, but you want to avoid this kind of fallback font appearing for way too long, because designers will not be happy, because the rendering is different. So what you end up doing is the same idea that you apply to critical CSS for rendering faster, you apply to web fonts as well, where you create a subset, right? A very small subset of the font that you're loading fast. Maybe it would have lowercase, uppercase punctuation, things like that. And then you render the entire file asynchronously later. Right, so this is a front critical fourth technique. But you can also do more than that. One of the interesting things is progressive font enrichment technique, which actually Jason Parmenter wrote about last week, where the idea is actually similar, but it's better. Where you also have a two-stage render, but it's a dynamic subsetting. Meaning, you have a minimal subset first, which actually captures only the glyphs you're using on a certain page, right? So only these glyphs will be loaded and then displayed and rendered right away. And then you asynchronously load the rest of the font, not the entire full font, but the rest of the font. You patch both of them, you store them in the service worker, and you have it. It's really more difficult. I mean, it's really hard to get better than that, right? And the results are quite noticeable. So if you look into what Google Fonts would send today, the result of that kind, and depending on the page, of course, that you have, will be maybe only 30% of the initial font file, which is actually quite noticeable. That's pretty cool. And in fact, you can combine it with the technique that we call the critical two-stage fourth render with the service worker. Feel free to, it's my abbreviation. Feel free to tattoo it if you want to. C2S, FOFT, RSW. The idea is exactly the same. You have two stages. And then you put it in the service worker instead of HTTP cache. And you might wonder at this point, what's wrong with this HTTP cache? And what's the big deal? Why do we need to go to all this effort? And in fact, there are tools for that. Right? You can say, let's explore what glyphs we're using on a certain site or on a certain page and load only these glyphs, right? And there's a font subset that allows you to actually cut out the things you don't need. And there is sub-font routine, which allows you to plug in this script in your page, and then it's going to capture what glyphs you're using, and then it's going to extract the rest of the glyphs from the font, and then it's going to inline it in the head, and then it's going to download the rest asynchronously in, as a separate file and patch it, and you might wonder why. Why do we go to all this trouble? What's the deal with HTTP cache? Why don't we just use HTTP cache? Well, the reason is very simple. Anybody remembers this article? Okay, I'm very old, I'm sorry. This is an article from 2007 where Yahoo decided to test the reliability of HTTP cache. And what they found out back then was quite surprising, because 40 to 60%, when Yahoo was a thing, by the way, 40 to 60% of Yahoo's users have an empty cache, although they were supposed to have a fully cached, right, where all the assets should be in there. Facebook decided to repeat that experience, this experiment, in 2015, and they realized, that's kind of confusing. Essentially, they saw the same thing, where 40%, on average, 44.6% of users are getting an empty cache, although they should have all the assets in the cache. Now, why is that? Well, the thing is, HTTP cache is extremely unreliable, right? If you look into Chrome's cache hit rates, we'll find out that the first files that are going to leave the HTTP cache are always fonts, followed by JavaScript, followed by images, followed by CSS, right? So these are the first files to leave the cache, which means every time a user comes to the page, there is maybe 40 to 50% chance that they're going to reload the entire app, or that they're going to re-request the entire font file, which is going to cost your performance, of course, right? But if you put things in a service worker's cache, it's a bit more reliable. But it also has limits, because, for example, Safari has at most the maximum limit of 50 megabyte for a cache, for service worker cache, right? So this is something we have to deal with. One other thing that could be useful there, I'm totally running out of time. One other thing that could be useful there is to think about grouping loading of fonts. Hold on just a second. I didn't get to my favorite part. Right. Just a second. I have to jump here. Yes, right here. So one thing that often happens is the case that when we load a font, we end up with this awkward experience where one font changes from a fallback font to web font, then the other, and then the other, and then the other. But this is very disturbing, especially on a slow connection. So instead, you can group repaints, which is much better, where you say, OK, let me make sure that all the fonts are there, and then there is one single switch from the fallback font to all web fonts, instead of changing bold and then italic and then regular and then book and so on and so forth, right? And then finally, the very last thing I want to mention is the changes in workflow that we have as well at this point. And that's really important because it kind of changes everything, really. I mean, I'm sure that most of you might have heard of Houdini. This says Houdini. Or anybody's excited about web components? No, only a little bit of excitement about web components. I'm almost finished, I promise. Well, when you put them together and you look at the bright, shiny new world and the future, this looks incredible. It really does. Now, first of all, what is Houdini? Houdini is actually, comes from Houdini. Houdini was known for two things. He was a great magician. He was very good at ruining life of his colleagues. Meaning, he would go to the magic shows, understanding or kind of exploring how they did a trick, and then write about it in a public newspaper. That's very nice, right? So he was exposing the details of things happening behind the scene. And it's a set of low-level APIs that give developers hooks into the browser styling and layout mechanisms. And that's quite remarkable because it doesn't require a lot of work. In the past, this is how things used to be for CSS, right? Somebody would write a spec, propose a feature, write a spec, browsers would implement it, then wait for browser adoption, and eventually use a feature. In JavaScript, it was different. You would propose a feature, you write a polyfill transpiler plugin, and you use it. So the idea is to bring this world of JavaScript into CSS as well, so we can actually polyfill easier, right? So this is what it's going to look like. I know, just a second. This is what it's going to look like. At this point, as of now, we have full JavaScript access to the DOM and partial JavaScript access to CSS OM, right? In the future, we can essentially adjust everything. You want to write your own parser? Go for it. You want to adjust Cascade or block Cascade at some point? Go for it. You want to change layout? Go for it, right? And the way it works is quite easy. In CSS, you want to write a new property, go ahead and just write it, right? So you would register a new pane, for example, or worklet, as they're called, and then you would go ahead and use it, and maybe even use a post-CSS plugin to make it work, and maybe even a Webpack loader as well. In the custom function or custom pseudo-classes, just write it with a little bit of JavaScript on top, right? And what it really gives us is something quite remarkable. Because as a result, when we look into the workflow, we are moving towards the world when, as we're writing CSS, kind of doing it the same way like we do with JavaScript. If you also connect it with CSS custom properties, for example, right? With CSS traditional way, we write it from scratch, we copy paste, and we write again, and we write again, and we write again. With JavaScript, we import a library, widget configs that the library provides, and we share the library to the package management, right? With Houdini and CSS, we end up, you import a worklet, you edit your custom properties in the same way, like it's like getting a function that actually does something in CSS, and then you share that worklet, right? And if you look at the browser support, no, we're not there yet, but it's actually getting to the point where this would be the way of writing CSS, right? You would have your background properties, or you have your custom properties, you would plug them in a function like you would, or in a method like you would usually do, and then you go ahead and use it. And it's not quite ready yet, but we're getting to the point that it's actually gaining a really good support. So this is going to be the future, especially when connected with web components, which essentially allows us to write a component, and you can use it in React and Angular and all the other things. Super, super excited about it. So just to wrap up, there are a few things happening, and I mean, it could go forever. This deck alone is like 739 slides and stuff. So we could go for it like forever. And this is only things that happened over the last month or so. It's really difficult to keep up. And I learned one thing the hard way. It doesn't matter what you do, you will never get it right. So I want to leave you with this video. Do I have the audio here as well? Hold on. I think I do. This is the story of my life, and this probably is a story of your life as well. You will never get things just right, and that's okay. I have audio as well. So thanks to Pearl Studio for the video. That's Front-End Development 2019. Welcome to the shiny new world. With this in mind, I have cats, and I have some stickers and books outside. So if you have any questions, please come there, because I think I've been thrown out of the stage. So thank you for coming, Meow, and I see you a bit later.
Thank you, Vitaly.